Welcome. This is the fourth video about numerical summaries, and in this video we're going to keep talking about standard deviation. And the main thing we're going to try to accomplish here is give ourselves some interpretations, add a little bit of intuition or feeling around the numerical summary that is standard deviation. So the object of standard deviation is to give a measure of spread. And what that means is that if your data is more spread out, then standard deviation will be larger. If your data is more scrunched together, then the standard deviation will be a smaller number. So let's witness that in this example right here and actually compare standard deviations without calculations. So you have two data sets, each has 6 numbers in it, and from the look of it, both of the data sets are kind of centered around 5. In fact, let's draw a number line and let's put our numbers on that number line. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I guess we don't really need to go that far. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And let's just go ahead and give ourselves a bigger radius there. And so we have 2, 4, a couple 5s, a 6, and an 8 for dataset A. And for dataset B, we have 1, 3, 2 5s, a 7, and a 9. I don't know why I did A on top and B on the bottom. But at any rate, this is a visual representation of both the data sets, so we should actually kind of color code them. B is the purple one, and A is the turquoise one. And so by inspection, because the purple dots are more spread out from the center, because the purple, the data set A is more spread out, the standard deviation will be larger. So both of the data sets are kind of centered around 5, but because the purple is so much farther away from the center, you can expect its standard deviation to be larger. So let's look at this next example. Suppose the average price of homes in the town of Ames, Iowa, sold between 2006 and 2010 is that. That's your average price of a home. The standard deviation is given as $80,000. So then it asks you, between what two values do we expect to find most homes are sold? And so this is supposed to be an interpretation of standard deviation. Standard deviation says typical homes, typical prices are are less than $80,000 away from the average. So if we take $80,000, so $181,000 is the average, minus $80,000, we get $101,000. And $181,000 plus $80,000, which equals $261,000. So our values we expect all homes to be, or most homes to be sold between. Our values expect most homes. It's like, okay, there's a center, at the average. And we know that the prices of homes will vary some from that center. But you shouldn't, it'll be somewhat surprising if you vary more than the standard deviation away. So it's like 261. So what we're saying is most homes are sold somewhere in this range. And right, you can expect that even more of the homes will be sold closer to the average. But it's just kind of a way to get a feel for what standard deviation is trying to communicate. Certainly there'll be even some homes that are sold across the whole spectrum. But it's where is the density of most of the homes? And the standard deviation is saying, okay, well, most of the homes should be within one standard deviation of the mean. So that's a common phrase you'll hear, is within one standard deviation of the mean. And then this last comment says observations are going to be considered an outlier if they're farther than 2 standard deviations away from the mean. So if we go even farther here to 341,000 or less, 21,000, then if the price of your home is larger than 341 or less than 21, that's what we're going to call an outlier. So it's just a way to make a decision. You're like, well, what if your home costs $22,000? Doesn't that seem kind of weird too? And you're like, yeah, that would be if you were a real estate agent and you were looking at data sets and you were looking at this data set really closely. Yeah, you would care if there was a home that was being sold for $340,000. It just gives some kind of rule to determine what is and what is an outlier. And so it makes the definition more exact. So I hope this helped clear up a little bit about what standard deviation is trying to tell you, and I will see you in the next video.